All right, we're here to continue the second part of section 7.1, 7.2, graphing of exponential function, particularly with graphing the transformation of exponential function. Okay, so we continue now with the problem with y equals 3 to the x minus 4 with minus 2. So there are two transformation involved here. First, just by looking, we know the minus 4 tells us to go where? Left, or right? It goes to the right. By how much? 4 units. Okay? The minus 2 here, which is another term, will tell you to go down by 2. Okay? Something that we should know by now. Okay? But again, we always start with identifying the parent function. For this problem here is y to the 3x. X, y. We have done this several times. So negative 2, negative 1, 0, 1, and 2. Try to do it without using a calculator. Negative 2, you plug it there, 3 to the negative 2, which is a negative exponent. So the 3, which is numerator, has to go down. That becomes 1 over 9. 3 to the negative 1, which is numerator again of 3. But there's a negative 1, so that goes down, which gives us 1/3. 3 to the 0 will always be equal to 1. 3 to the 1 is 3, and 3 squared is going to be equal to 9. Let's graph it. 1/9 is right here. 1/3, 1, 1/3, that's not 3, and 2 to the 9th. And the graph of our parent function is like this, wherein the horizontal asymptote is the orange one. Y is equal to 0. This y is equal to 3 to the x. Now we have minus 4, minus 2. The transformation for this one is that you go to the right 4 and down 2. So all the black points will go to the right 4 and down 2. Let's do it now. So right 4, 1, 2, 3, 4, down 2. 1, 2, 3, 4, down 2. 1, 2, 3, 4, down 2. And then just a pattern there. Now the asymptote you can see will just go down by 2 units. So this will be y equals negative 2 as the horizontal asymptote here. If we connect all those purple points, we will have a graph like this. In the domain there will be the same, all real numbers. The range there starts from negative 2 going to positive infinity. You good? So just a quick review, if we have y is equal to 1/2 x minus 2 plus 7, tell me the transformation here, please. Y is equal to, let's say, 2 to the x minus 5 minus 5. Can you tell me the transformation for this problem? Y is equal to 2 to the x. Y is equal to 1/2 2 to the x. How do they differ? Which one here will give a steeper graph? The first one or the second one? And as you answer all this one here, make sure that you answer this charge of yours, okay? I may not have exact paper for you to do this one, but I would like you to copy this one on your notes, okay? All right. Next, I would like you to graph another problem here just to make sure we covered everything. What if we're given y is equal to negative 3 to the x? What is the parent function of this graph here? The parent function here is y equals 3 to the x. Although this is the reflection across the x-axis. So we will do the same thing as how we normally do it. -2, -1, 0, 1, 2. And you should know by now that this will be 1/9, 1/3, 1, 3, and 9 there. If we graph it, we're going to have a 1/9 here, 1/3, 1, 1, 3, and 2 to the 9th there. So what's the implication if this is negative? What happened there, the y value flipped all the signs here. So the y now for this problem will be now -1/9, -1/3, -1, -3, or -9. That means this points will flip over, which will be this orange point. If you notice, is just a perfect reflection across the y-axis. The first one here has a purple graph, which is like this. This is the graph of y equals 3 to the x. But the y to the -3 to the x will be this. I missed it, sorry. That graph there. So if you can see, it's just a reflection across the x-axis. Okay, there you have it. I hope this helped you. And again, I would like you to copy this one here on your notes, complete it, answer it, and there you go. All right, kaboom.